Hello everyone, and welcome back to YouTube Daily Military, Tampa Bay Airfest 2023 Static Display Aircraft, T-38 Talon. The T-38 Talon is a twin-engine, high-altitude, supersonic jet trainer used in a variety of roles because of its design, economy of operations, ease of maintenance, high performance, and exceptional safety record. Air Education and Training Command uses the T-38C to prepare pilots for frontline fighter and bomber aircraft such as the F-15 Eagle, F-16 Fighting Falcon, B-1B Lancer, 10 Thunderbolt and F-22 Raptor. T-38s fly in Sentry Savannah, U.S. Air Force. T-38A Talons assigned to the 2nd Fighter Training Squadron fly over during Sentry Savannah 22-1, May 4, 2022. The Northrop T-38 Talon is a low-wing jet trainer aircraft built in the United States during the 1960s. Used to train military pilots and NASA astronauts, it was the first supersonic jet trainer aircraft and more than 1,100 were produced. Still widely used today, it is considered one of the safest supersonic jet aircraft. It is estimated that more than 60,000 pilots have been trained with this jet device. 9 AMXS B-Roll Package 2, the 9th Aircraft Maintenance Squadron services planes including the U-2 Dragon Lady and T-38 Talon on Beale Air Force Base. The Northrop T-38 Talon is a two-seat, twin-jet supersonic jet trainer designed and produced by the American aircraft manufacturer Northrop Corporation. It was the world's first supersonic trainer as well as the most produced. The T-38 can be traced back to 1952 and Northrop's N-102 Fong and N-156 fighter aircraft projects. During the mid-1950s, Northrop officials decided to adapt the N-156 to suit a recently issued general operating requirement by the United States Air Force, USAF, for a supersonic trainer to replace the Lockheed T-33. The bid was successful, in no small part on its lower lifecycle cost comparisons to competing aircraft, and the company received an initial order to build 3 prototypes. The first of these, designated YT-38, made its maiden flight on April 10, 1959. The T-38 was introduced to USAF service on March 17, 1961. The USAF is the largest operator of the T-38. In addition to training USAF pilots, additional operators of the T-38 include NASA and the United States Navy. U.S. Naval Test Pilot School in Patuxent River, Maryland, is the principal U.S. Navy operator. Other T-38s were previously used by the U.S. Navy for dissimilar air combat training until replaced by the similar Northrop F-5 Tiger II. Pilots of other NATO nations have commonly flown the T-38 during joint training programs with American pilots. The T-38 remains in service as of 2023 with several air forces. As of 2023, the T-38 has been in service for over 60 years with the USAF, its original operator. In September 2018, USAF announced the replacement of the Talon by the Boeing Saab T-7 Red Hawk with phase-out to begin in 2023. Missing man formation. 4 T-38 Talons assigned to Whiteman Air Force Base performed a missing man formation during the Lieutenant Whiteman wreath-laying ceremony, Sedalia, Missouri. This aerial salute is one of the ways we choose to honor those who have fallen. The B-roll package includes cockpit footage of flyover and ground footage of flyover. B-roll. Shepherd AFB Airman pit stop at Minot AFB, 80th Flying Training Wing airmen from Shepherd Air Force Base landed their T-38 Talon at Minot Air Force Base to refuel before taking off again to fly to the Cold Lake Air Show in Canada on July 14, 2022, at Minot AFB, North Dakota. The 80FTW is the world's only internationally manned and managed pilot training program, with the Euro-NATO Joint Jet Pilot Training Program delivering more than 7,500 trained combat pilots to NATO allies in its 37 years of existence. In 1952, Northrop began work on a fighter project, the N-102 Fong, with shoulder-mounted delta wing and a single engine. The proposed General Electric J-79 engine, weighing nearly 2 tons, meant the resulting aircraft would be large and expensive. During 1953, representatives from General Electric Aviation's newly created Small Aircraft Engine Department showed Northrop a relatively compact engine, around 400 pounds installed weight, capable of 2,500 pounds of thrust, and Northrop VP Engineering Edgar Schmude saw the possibility of reversing the trend toward the large fighters. Schmude and Chief Engineer Welko Gazik decided on a small, twin-engined, hot rod fighter, the N-156. Northrop launched its N-156 project in 1954. Aiming for a small, supersonic fighter jet capable of operating from the U.S. Navy's escort carriers, when the Navy chose not to pursue equipping its fleets in such a fashion, favoring large fleet carriers instead, Northrop opted to continue work on the N-156 using in-house funding. It was instead recast as a lightweight fighter, referred to as the N-156F, that was primarily aimed at the export market. In the mid-1950s, the USAF issued a general operating requirement for a supersonic trainer, seeking to retire its 1940s-era Lockheed T-33s for an aircraft that would be better suited to training pilots to fly its high-speed fighter aircraft. Northrop officials decided to adapt the N-156 to this competition. The only other candidate was the two-seat version of the North American F-100 Super Sabre. Although the F-100 was not considered the ideal candidate for a training aircraft, it is not capable of recovering from a spin, NAA was still considered the favorite in the competition due to that company's favored contractor status with the USAF, but Northrop officials presented lifecycle cost comparisons that proved to be highly persuasive amongst USAF officials. In 1952, Northrop began work on a fighter project, the N-102 Fong, with shoulder-mounted delta wing and a single engine. The proposed General Electric J-79 engine, weighing nearly 2 tons, meant the resulting aircraft would be large and expensive. During 1953, representatives from General Electric Aviation's newly created Small Aircraft Engine Department showed Northrop a relatively compact engine, around 400 pounds installed weight, capable of 2,500 pounds of thrust, and Northrop VP Engineering Edgar Schmude saw the possibility of reversing the trend toward the large fighters. Schmude and Chief Engineer Welko Gazik decided on a small, twin-engined, hot rod fighter, the N-156. Northrop launched its N-156 project in 1954. Aiming for a small, supersonic fighter jet capable of operating from the U.S. Navy's escort carriers, when the Navy chose not to pursue equipping its fleets in such a fashion, favoring large fleet carriers instead, Northrop opted to continue work on the N-156 using in-house funding. It was instead recast as a lightweight fighter, referred to as the N-156F, that was primarily aimed at the export market. In the mid-1950s, the USAF issued a general operating requirement for a supersonic trainer, seeking to retire its 1940s-era Lockheed T-33s for an aircraft that would be better suited to training pilots to fly its high-speed fighter aircraft. Northrop officials decided to adapt the N-156 to this competition. The only other candidate was the two-seat version of the North American F-100 Super Sabre. Although the F-100 was not considered the ideal candidate for a training aircraft, it is not capable of recovering from a spin, NAA was still considered the favorite in the competition due to that company's favored contractor status with the USAF, but Northrop officials presented lifecycle cost comparisons that proved to be highly persuasive amongst USAF officials. JID 3/ADE 5, T-38's RAP, U.S. Air Force Captain Hannah Myers, Wright, 586th Flight Test Squadron Flight Engineer, and Nate Vogel, 586th FTS Pilot, conduct pre-flight procedures in a T-38 Talon during the Global Information Dominance Experiment 3 and Architecture Demonstration and Evaluation 5 at Alpena Combat Training Center, Alpena, Michigan, July 16, 2021. NORAD and USNRTHCOM, in partnership with all 11 combatant commands, led the third in a series of global information dominance experiments designed to rapidly develop the capabilities required to increase deterrence options in competition and crisis through a data-centric software-based approach. GED events combined people and technology to innovate and accelerate system development for domain awareness, information dominance, decisional superiority, and global integration. The GED-3 experiment was executed in conjunction with the Department of the Air Force's Chief Architect Office, DAF-CAO, as part of their 5th Architecture Demonstration and Evaluation Event, ADE-5, and the Joint Artificial Intelligence Center.